So while everything is like booting and loading up, you should notice that there's a poll available on Zoom, right? So go ahead and take that poll. The poll is basically, hang on. The poll is, because on Monday we took some time to do one-on-one sessions and, review our midterm grade and just try to position as many people for success as we could. So today, we have a choice. We can either go through the lecture for this section or we can go through the homework. My earlier class chose to go through, let me go ahead and get into some here. Oh, he popped in and popped out. There he is, okay. My earlier class chose to go through the homework. Let's see what the poll is looking like right now. Yeah, right. That's what I feel like is the best move, is to go through as many of the homework questions as we can, because this lecture is already available. You can access it, and I'll fill in what I need to fill in as we go through the homework as best I can. So we'll take some time to go through as many of the homework questions as possible. So then let me relaunch, but I want to launch the second one. Okay. All right, that's fine. So I'm gonna hold off on that for right now. I just want to close this. And I'll check back, around the 15-minute mark for people that are coming late. So let's just take some time and go through as many homework questions as we can. So let me see, we took exam 2, right? So we're moving on to the next section, which is chapter 6. So we have 3 sections in chapter 6. So today we're going to be starting with section 6.1, sequences and series, right? Let me see. To summarize this experience, now obviously there's more details than what I'm about to say, but a brief summary, most of the sequences and series, or most of the sequences that we come across, it really falls into 2 main categories. There's a series called an arithmetic sequence. Sorry, there's a sequence called an arithmetic sequence. Arithmetic just means we keep adding the same number at each step, right? We might add a positive or we might add a negative, but we're adding the same thing at each step. Versus a geometric sequence, we're multiplying the same thing each step, right? So usually it falls into one of those 2 categories. So those are the main 2, either arithmetic, where we add in the same thing each time, or geometric, where we're multiplying the same thing each time, right? So let's just see what happens. This one asks us to write the first 5 terms of the sequence whose general term an is given. Now, obviously there are other nuances and details, but that's a brief summary of like what we're going to be engaging. So we have the general term is given, and they want the first 5. So this subscript n, this a sub n, this is a general form of the sequence, right? So where n is going to be a positive counting number, right? So n is going to be basically 1. We let n be 1, we let n be 2, we let n be 3, so on and so on and so on. So in this example, they want the first 5 terms of the sequence. So when n is 1, or in other words, the first term in the sequence, -9 plus 3 is -6. So I'm going to put -6 because I let my n be 1. Okay, my n is 1 there. So when n is 1, the output is -6. Okay, this is like a recursive form. Okay, well, it's not really recursive in this case. So now when n is 2, the second term in the sequence, so -9 times 2 is what? -18, plus 3 is -15. Okay. Let's keep going. So now when n is 3, is -27 plus 3 is -24. Okay, and again, if anything isn't clear, feel free to unmute yourself to get my attention and we can talk about it. When n is 4, -36 plus 3 is -33. Okay. And when n is 5, -45 plus 3 is -42, right? So with this general form of the sequence, we were able to generate any term in the sequence. If n is 1, or if we want the first term, we let n be 1. If we want the second term, let n be 2, so on and so on and so on. Right? So we generated the first 5 terms in that sequence. Here we're asked to write the first 4 terms in this sequence whose general term is given. So the first term is found when we let n be 1. So then 2 divided by what? 9. So we're going to leave that as 2 over 9. 2 over 9. Okay. When n is 2, that's going to be 4 over 10, which becomes 2 over 5. Yeah, it should be 2 over 5. Okay. So then for the third term, we let n be 3. 6 over 11. Okay. And then when n is 4, 8 over 12, 4 over 6, 2 over 3. All right. So it reduces down to 2 over 3. Okay. And again, just stop me if anything is not clear. Otherwise, I'm just going to chug along. Write the first 5. Let me see the time. Let's give another 2 minutes. Write the first 5 terms of the sequence. So again, the general form of the sequence is given. They want the first 5 terms. So the first term, we let n be 1. So then when n is 1, we're going to have -1 to the power of 4. So a negative number to an even power is a positive number. So it's just going to be 1. I think it's just going to alternate each time. Because when n is 2, we're going to have -1 to the power of 5. A negative number to an odd power is going to be negative. So it's either just going to be, in this case, it looks like it's going to be -1 or 1. And it looks like it's just going to keep alternating. So I'm just going to put 1. Then I'm just going to put -1 and keep it moving. Hopefully that makes sense as to why that's happening here. I'm just going to put 1. Come on. Okay. Got time for another one. Write the first 4 terms of the given sequence. Type in integer or decimal. Okay, notice that there's no n on the right-hand side, right? So we have a sub n equals 1.2. So no matter what term we're looking for, the output is always just going to be 1.2. So all of these should just be 1.2. All right, because there's no n to manipulate the right-hand side. I guess that's okay. So just for this one, I'm just putting 1.2 because again, there's no n on the right-hand side to manipulate it. So that means all the outputs are 1.2. First 4 terms whose general sequence is given. Let me see the time. Okay, let me check Zoom really quickly. Okay. It's okay. Let's see. People are feeding, but that's okay. All right. First 4 terms whose general term is given. All right. So when n is 1, on bottom, it looks like we're going to have what? 2 factorial, which is 2. On top, we're going to have 1 to the power of 3. So it's just a half. So factorial, that little exclamation mark you see on the bottom, that means, let me see, hang on. Oh, when n is 1, 0 factorial is 1, so that output is 1. So it's just 1. So factorial means it's like if you had whatever number you have factorial, you take that number times the number before it, times the number before that, times the number before that, and you keep doing that until you get to 1, right? So for instance, 3 factorial means 3 times 2 times 1. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, right? By definition, 0 factorial means 1 or is 1, right? That's by definition for this stuff to work. Okay, so that exclamation mark just means factorial, the way we describe. So for instance, when n is 2, right? When n is 2, on top we're going to have 8. On bottom we're going to have 1 factorial. 1 factorial is just 1. So that means the output is just 8. When n is 3, 9 times 3 is what? On top we're going to have 27. On bottom we're going to have 2 factorial, which is just 2. So I guess we can leave it as 27 over 2. Okay. When n is 4, is it 256? Hey Siri, what's 4 times 4 times 4 times 4?
4 times 4
Nope,
times
nope,
4
nope,
times
nope,
4 is
nope.
250.
No, that's not what we're doing. 4 to the power of 3. 16 times 4 is what, 64? So on top we'll have 64. On bottom we'll have 3 factorial, which is 6. 64, 32. Okay, 32 over 3, right? Obviously I should be writing this out. I'm just not. All right, but if I need to, just let me know. Write the first 4 terms of the following sequence, okay? Okay, so like if we let n be 1, right? So maybe I should write this one out. I'm gonna write this one out. I think I checked attendance. I'll check attendance again a little bit later. But I usually check it like at the start of class. Then I check it again at the 15-minute mark, which I already did. So then the rest is like, you're lucky if you get in at that point. It just depends on if I check or not. They want the first 4 terms. Let's get a copy of this. Let's hop over here. You can drop it here and let me. Let's add a page. Let's move this like here. And then let's add a few more pages. Okay. And right here. Come on. Okay. So the first 4 terms, right? So if we want the first term, that's going to be, we're letting n be 1. So that's going to be -1 to the power of n plus 1 times 3 to the power of -1, right? And again, 1 plus 1, 3 to the -1. Okay. So then a negative to an even power becomes positive. So the final result looks like it's 1 over 3 for that one. Okay. They want the first 4 terms. So let me just copy and paste. Let me copy, paste. Oh, you're doing that thing. Can I like move you off of it? That would be nice. Let me undo. Okay, I think I just made the circle too big. Copy, paste. Okay, that's better. And then let's get rid of this guy. And copy. See, that's the first, second, third, and the 4th. This is fine. I'll fix it. Okay. Why is it doing that? Come on. Come on. There we go. So this is the second term. It's going to be 2 plus 1 to the -2. The third term, 3 plus 1 to the -3. The fourth term, 4 plus 1 to the -4. And all of these results are going to be different. Okay. So if we're working on the second term, -1 to an odd power is going to be negative. 3 to the -2 is basically 1 over 9. Okay. This one's going to be positive 1 over 27. And then negative 1 over 81. Okay, I think we got it. 9, 27, 81, positive, negative. Okay. So 1/3, I think was the first one. Okay, then it was a negative 1 over 9. Then a positive 1 over 27. And then a negative 1 over 81. Check on you guys' Zoom. Okay. Go on to the next one. Okay, predict the general term or the nth term of this sequence. Okay, so this is like one of the ones that I was talking about in the opening, in the opener today, or in the introduction today. Like the main two that we typically come across is not solely limited to that, but a lot of them fall into one of those two categories. It might be arithmetic, where we're adding the same thing each time, or it might be geometric, or multiplying the same thing each time. So like first we can try arithmetic. Let me see. So what, 5 plus 4 is 9, plus 4 is 13. It looks like we're adding 4 each time, right? So let me think about it. Now I'm trying to pull this from memory, the general term of the arithmetic. So the general term, predict the general term, is going to be basically the first term plus n minus 1 times d, right? So in general, like for arithmetic sequence, is going to be basically a sub 1, right? And I'm not going to submit this, but it's a sub 1 plus n minus 1 times d, right? So where you have your first term of the arithmetic sequence, and then your d is your common difference, right? And we can test this out. For instance, we're given that the first term is 5, right? So when n is 1, the output is 5. When n is 2, it's going to be 5 plus, what do we say, 4, which is 9, right? So I feel good about this. So now we can plug in a lot of this stuff, right? We know the first term. So if you have a formula sheet, you might want to screenshot or something like that. This is the general form for arithmetic sequence, right? Once you identify that the sequence is arithmetic, meaning we're adding the same thing each time, this is the general form of arithmetic sequence, all right? So you might want to get a copy of this and add it to your formula sheet. Hopefully you have a formula sheet. So now our first term, our A1 is 5. Usually that's given, right? So we're going to change A1 to 5. We're going to leave n minus 1. And the common difference, we're increasing by a step of 4 each time, right? So then we can simplify this. If we distribute that 4, if we distribute the 4, we're going to have 4n minus 4. And then it's still plus 5. So then that changes to plus 1. Let me get rid of all the other stuff I'm not using. Yeah, get rid of all of this, okay? So now, before we submit it, let's test it. When n is 1, the output should be 5. Okay, we didn't do something right. Maybe it was plus. I think it's supposed to be plus 1. Let me try plus, and if that doesn't work, I'll go back. So when n is 1, we get 5. When n is 2, 8 plus 1 is 9. When n is 3, 3 times 4 is 12 plus 1 is 13. When n is 4, is 16 plus 1, 5. Okay, so this is good, right? Somehow, I don't know why I put minus, right? So I took that general form of an arithmetic sequence. I plugged in the first term and the common difference, and then I simplified, and I got here. If I need to write that out, you just have to get my attention and request it. Okay. Okay, so let's see if we can identify this as one of those two that we mentioned. Okay, let me use my calculator on this one. Cool. Reload. Refresh. That looks good. There it is. Cool. Okay. So first I want to test to see, is this a common, is this an arithmetic sequence? Are we adding the same thing each time? So I'm going to do 2 divided by 7 minus 1 divided by 6. I'm going to hit math as a fraction because I want to try to keep it as a fraction. Okay, now let's add that. Let's say that plus, let's start over, 5 over 24. So let's say 2 over 7 here. Let's start from the beginning. 1 over 6 plus 5 over 42. We get, let's hit math as a fraction. We get our 2 over 7. So then we want to take that answer and say plus 5 over 42 math as a fraction. Right? And we don't get the same thing. So this is not arithmetic because we're not adding the same thing each time. So then next we would try, well, let's see if it's geometric. Are we multiplying the same thing each time? So to do that one, we're going to say, let's do parentheses 2 over 7 divided by 1 over 6. All right, I intentionally put those, each fraction in parentheses so I can treat them as a unit. I'm just saying the second thing divided by the first. This will give us a common ratio. Can we get it as a fraction? Okay, so it looks like we can try, maybe we're multiplying by 12 over 7 each time. Okay, let's see. 1, 2, 3, maybe not. 6, 7, 8, 9, 10. Maybe we're overthinking this one. This one's a little different. I think I see the pattern now. We can try this. I don't think it's going to work, but we can try it. So if we say 1 over 6 times 12 over 7, right? Math as a fraction. I think we get our second one, but then if we take that answer and say times 12 over 7 as a fraction, 24, right? So it's not geometric either. But while we were kind of going through that exercise, I noticed something, right? Notice that the numerators all go 1, 2, 3, 4, 5. The denominators are just going 6, 7, 8, 9, 10. Okay. Okay. So let me think about it, how I want to articulate it. Let's do this. So if we're trying to generalize this, I'm going to write it as a fraction. So let's treat these as two separate arithmetic because we're adding 1 each time, right? So the first one, we're starting with whatever the first term is plus parentheses n minus 1 times d. And we're essentially doing the same thing on the bottom. So I'm just taking notes right now. Ace, the first term plus, but I'm treating these as two separate sequences, n minus 1 times d. Now I probably should write this out, but now if we focus on the top, the first term for the top is 1. So I'm gonna change A1 to 1. And then we're adding the same thing. We're adding 1 each time. So the common difference is 1. So that D turns to 1. So then I can just get rid of that as well. So then if we finish simplifying, if we combine like terms, that positive 1 and negative 1 cancel each other out. So that just leaves me with n on top, okay? Then on bottom, the first term in that sequence is going to be 6. So I'm going to put a 6 here. The common difference, we're still adding 1 each time. So that's a 1. So it just gets absorbed. If I combine like terms, 6 minus 1 is 5. So I'm actually adding 5 each step there. And I think that's it, right? So that one was interesting because it was basically 2 arithmetic sequences combined into 1, right? So now if we let n be 1, we get 1 over 6. When n is 2, we get 2 over 7, 3 over 8, 4 over 9, yada, 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 all right? Okay, I feel good with this. Let's go with it. Look at God, all right? God is good. Because we tried arithmetic, that didn't work. We tried geometric, that didn't work. But then I noticed, oh, the top is arithmetic and the bottom, if you treat them individually and just adjust, you know. Let's try another one. That one was fun. So look at the pattern to predict the general term or the nth term of the sequence. So it looks like it's just flipping between 12 and negative 12, right? Okay, I kind of want to get you guys input. So let me see if the poll is active. We don't have that much, but I want to, let's do the polls and quizzes, general multiple choice. You can launch it. Okay. So for this example, there is a poll that is active on Zoom. What do you think the correct choice is? Do you think it's, okay, wait. I think if I go like this. Okay. So look at the pattern and predict the general term. Which is the general term or the nth term of this sequence, right? So which one of these works? When n is 1, the output needs to be negative 12. When n is 2, it needs to be 12. And it's basically, the output is always 12, but it's alternating between negative, positive, so on and so on. So which output, A, B, C, or D, does that, right? So I think there is a vote for A, but I don't think A works. But C is closer, but that doesn't work either, because when n is 2, you're going to get a positive like 144, right? And the problem with A, the exponent, so A is order of operations, right? A, that exponent, that power of n only applies to the 12, the way it's written. So that means that negative is going to persist all the way. I think there's a vote for B. Okay, B is like really close, but again, the trouble with B is the order of operations is off. It's very subtle, right? I'm glad we did this, right? So I think B and D are our candidates, right? But the trouble with B is order of operations, right? So the way it's written, you would do the exponent first, and then you would multiply by that negative. So that means that it's going to force it to always be negative. If we want that sign to alternate the way that it's behaving, I think it has to be D, right? So when n is 1, we get a negative. When n is 2, we get a positive, so on and so on and so on. I'm going to go with D. Okay, that was good. Like, I'm glad we did that. All right, I'm going to let that poll just kind of ride out. Let me check the answer. That's good. Let me see the time. We got a solid 10 minutes. Let's keep going. That was good. That was a good exercise. Predict the general term or the nth term of the sequence. Okay. Now this is kind of weird. It looks like it's saying 1 times 2, 2 times 3, 3 times 4, 4 times 5. So we can kind of repeat like we did the other one where we noticed 2 arithmetic sequences in one. So we can kind of do something similar here, right? So I'm gonna do parentheses. Hang on, go away, come back. Okay, I'm gonna do parentheses for the first number, and then I'm gonna say times whatever that second number is, right? So to capture that first number, again, the general term, and I think these are both arithmetic. So that means we're gonna have a sub 1 plus parentheses n minus 1 times d. And that basically happens twice. A sub 1 plus, and I'm kind of just taking notes here, n minus 1 times d, right? So now when we look at that first sequence, we're basically going 1, 2, 3. The first term is 1. So we're going to change A1 to 1. The common difference is 1 because we're adding 1 each time on that first part. And so then when you combine like terms, I think you're just left with n there. All right, so it's kind of the same thing as we had before. And I'm going to go ahead and lose these parentheses. All right, so the first sequence reduces down to just n. Now the second one, the first term starts at 2 instead of starting at 1. All right, and again, the common difference is 1, so this d turns into a 1. It gets absorbed basically. When you combine like terms, you're left with n plus 1. All right, this is gone. The rest of this stuff is gone. Oh, actually, we need this parentheses. Okay. So the general term, so this is the form that it's taken on. So for instance, when n is 1, we get 1 times 2. When n is 2, we get 2 times 3. When n is 3, 3 times 4, yada, yada, yada. All right, so any n that we want, it ends up taking on this form. So I like this stuff because it makes me think. Like, you know, it's probably making me more jaded. I try to connect with people, but man, people are just, I can't keep up. I get overwhelmed so easy. And it's like, I feel like when I'm engaging people, I'm always dealing with either their ego or my ego. And I'm trying to remove egos out of the picture, right? So that's why I like math. That's why I fell in love with it, because it broke things down to the simplest form. I know when you engage people, it don't really work like that. But there are a lot of processes that we use that use this kind of energy and this kind of like engagement or whatever. Breaking things down to its simplest form, you know, the simple shapes, breaking it down to its simplest form, and then finding the holes or the gaps that you can like explore or manipulate or fill in or do whatever it is you need to do, and then build it back together and keep it moving. Like that's what a lot of math is. It's what I just described there is what a lot of it is. Anyway, we got a solid like 5 minutes, so let's try to get through some more. Write a general term for the sequence. Assume that n begins with 1. Okay. Let me see. So that 7 looks like it persists. 6, 7, 8, 9. And we want the general form. So we can kind of do something similar to what we had before, right? So I'm going to say 7 plus 1. The only thing that's changing is that denominator, right? And that's still an arithmetic sequence. So this is going 6, 7, 8, 9. We're adding the same thing each time. So we can still use the a sub 1. Oh, that's not a 1. A sub 1 plus n minus 1 times d, right? And we just need to get that sequence. So now, with the first term, if we just focus on that guy, we're starting with 6, right? And then the common difference is still 1, so it gets absorbed. If we combine like terms, 6 minus 1 becomes 6, n plus 5. Okay. So let's see if this works. So when n is 1, it should be 7 plus 1 over 6. 7 plus 1 over 6, that works. Oh, wait a minute. I didn't see that minus, right? We got an alternating sign. So to capture the alternating sign, what we're going to do, let's see. We can put it here. It's basically going to be -1 to the power of n. That's usually how we capture. That's how we capture alternating signs. Okay. So let's see if it works. When n is 1, we need a positive. So let's see. If we want that to be positive when n is 1, let's put this as n plus 1. Okay. So now, when n is 1, that becomes positive, and we still have our 6, right? So we're good to go there. When n is 2, now the exponent is odd, so we get a negative output, and we get our 7, right? Yada, yada, yada. I think that's good to go. Type in expression using n as the variable, simplify your answer. I think I'm gonna go with this. Let's try this out. That was fun. That was a lot of fun. I don't know about you guys, but that was fun. Like, I don't know. It's like a little game or a puzzle. Let's keep going. I'm trying to get to 145, so let's go for another at least 4 minutes. Write the first 4 terms of the recursively defined sequence. So now recursive. This is similar to what we've been talking about, but it's a recursive form is basically a definition that feeds back on itself, right? So that an plus 1. So they gave us the first term, and then the recursive definition is saying all the subsequent terms are found by using this guy, right? So the first term is 7, and then to get to the next term, you do the previous term plus 6, right? So this form is based on the previous. That's why it's called recursive, because it feeds back on itself. So the first term is given, which is our 7, okay? And then it says, what's the second term? So when n is 2, so a sub 2 is going to be a sub 1 plus 6, so 13, all right? 13. So basically, we're adding 6 to the previous. So then 3, we just add 6 to that one, is going to give us 19. And then if we add 6 to that, we're going to get what, 25? Hopefully this makes sense on how we're doing this. All right. We got a solid 3 minutes. Let's keep it going. Write the first 4 terms of the recursively defined sequence. Okay. So they gave us the first term, which is 1. Okay. Then get to the second one. The definition says the n plus first term is going to be 3 times the previous plus 3. Right. So the second is going to be 3 times a1 plus 3. So 6, right? 3 times 1 plus 3 is 6. So then the third one is going to be 3 times 6, which is 18 plus 3 gives us 21. Now I'm not writing this out just because I feel like you guys can pick it up. For the fourth one is 3 times 21 plus 3, 63, 66. Get your kicks on root 66, okay? Let's keep going. We got a little bit of time. Simplify the following factorial. Now again, factorial just means, I kind of want to write this one out. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Actually, I can do it here. Okay, so 8 factorial means, I hate to write all this. Here. So I think you guys can understand that 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 1, right? So I'm going to leave it abbreviated as 8 factorial. Now that bottom is 11 factorial, which means 11 times 10 times 9 times 8 times 7 times 6 times 4 times 4, right? Let's start, we can start writing it out. So 11 factorial means 11 times 10 times 9 times. Now, if we're going from 8 all the way down to 1, then that's just 8 factorial, right? So then if we have 8 factorial on top and 8 factorial on bottom, a number divided by itself is 1. So that means this is gone, and then we just need to crunch that number. 99 times 11 is 99, so 990. So I think that becomes 990. Like that, right? 90 times 11. 9 times 11 is 99. Tack on a 0. Integer or simplified fraction. Let's cross our fingers. God is good. All right. Let's do one more. I see the time. We're just going to do one more. All right. Okay. So piggybacking off what we just did, right? We saw that when we did 11 factorial, once we hit 8 factorial, it was a repeat and we can cancel a lot of that stuff, right? So maybe we can have something like that going on here. So if we think about, let's write our fraction. So if we think about the numerator, 5n plus 2 factorial, that means it's going to be 5n, just that number, 5n plus 2 times, subtract 1, 5, thank you, 5n plus 1. Okay, if we subtract 1 again, now we can abbreviate, right? It's going to be parentheses 5n factorial, right? And then on bottom, we also have 5n factorial. So then those two cancel each other out. This is canceled by this guy. It would be nice if I could just get rid of the bottom, but that's okay. I'll get rid of it in a moment. So we're left with the first two. 5n plus 2 times 5n plus 1. Let me see. Let's see. Is there a way I can? Yeah, that's okay. So we got 5n plus 2 times 5n plus 1. I think that's all that was left, right? They might want us to FOIL that out. Let me try submitting this. Okay. I thought we were going to have to FOIL it, but. And with that, we are out of time. Let me check Zoom one more time. I can end this poll. Close. There. Back to the meeting. I think you guys are okay. I'm just trying to see. Oh, let me get the students in the next class. Yeah, I must didn't get this credit. It's fine. All right. Are there any burning questions for me before we end this session? We didn't really take that many notes, so I guess I can share it because I think, so you can get a copy of the instructor notes for this section. So I'm going to send it to Box, but the proper folder, come on. Fall, College Algebra 2, into the notes section, updated daily. 7, 8 was the exam, so this is week 9. Send to Box. Okay, so when that bar finishes loading, you'll get a copy of anything that you saw me writing. Hopefully those concepts made sense. It is a good idea to check out my pre-recorded lecture on this section because these notions are not obvious. I mean, push however you feel like you need to push. But yeah, okay. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. All right, take care. Peace.